NS all-in-one 2.34 software tar gz software, how you can download. And in Fedora 8 at the root, so you have to unzip that, means extract that particular NS all-in-one. In that you have to go in a terminal, you have to go to the folder directory NS all-in-one. So there a install file will be there, /install. So if you type and press enter, so installation will start. As I told you that it will installation is somewhat a long process. It has to install a many thousands together files. So based on that, almost all files are C++ files. It's keep on start installing according to the hierarchical folders. It will keep on installing. Finally, if installation is correct without any errors, it has been gone. A path, how to set a path, that message will be displayed at the last, and will come back to the hash prompt. So then what you have to do, then as I told you that setting a path is difficult according to that message, will go in another method. What is that? Again, we should go back to NS all-in-one. There a folder will be created by name called a bin. So you have to open that bin folder, copy all 13 executable files, whichever are there. Then you take that and open the sbin folder, which is there in a file system. Unix file system. There you copy all the 13 files. So from wherever you want, you can run now the NS files. The command to run a NS Tcl files is NS. So in a root hash prompt, if you type NS and press enter, automatically a percentage prompt should come indicating that you can do the Tcl instructions. That means that the installation has been done correctly. And we have again have shown you that how the NS 2.34 folder, in that folder how the different subfolders will be there. And in one DSDV we have seen that how dsdv.cc and dsdv.o and dsdv.h files will be there, and how we can define an object, how we are going to link that with the Tcl file to there. We have did that. After doing all these things, I've explained you one problem Tcl concept, that I've explained you that there will be a 3 nodes, that is N0, N1 and N2. N0 is connected to N1, N1 is connected to N2. But the source will be always N0 and N2 is the destination. Once the source and destination has been decided, so we have to add up the transport layer and an application layer to the source and a transport layer to the destination. That you keep always in your mind. So between nodes, nothing you should do. So once it has been decided that which is a source node and which is a destination node. And later on you should decide the traffic also, which data should be flowed in that, either TCP data or a UDP data. So according to the problem, we have seen that it's a TCP data. So a TCP will be attached to the node N0, and then a TCP sync will be attached to N2, where a virtual connection will be established from TCP0 to sync, TCP sync, where so that the end-to-end process will be done between TCP and TCP sync. So the side way of it. So as an application agent, we at a source side, we will attach the FTP agent to the TCP agent which has been attached. So then we will schedule the time. Now we will go back to that program and where we have stopped. That is the moment scenario we have did almost all. We'll go how a traffic scenario will be programmed. So that we'll discuss now. Now I will share the window of a Fedora, and we'll start with that particular thing. Now back here. Share. Right, now you can see here in a last class I have told you very clearly that this is the common things which will be there in all the NS programs, not only your lab programs, any NS programs if you are going to do this. Until here means that is initializing initializing the network simulator. That is, as I told you, that NS is one object here which has been initialized with the class called as simulator. Now NS will be the instant simulator. Now that for this particular program at that moment, a simulator will be created by name called as an NS. So within that simulation, within this NS simulation, we are adding up of the nodes and links and whatever flows, everything, components, everything will do the work that I told you. Coming to the next, there will be a two output files will be there. The one is a NAM animator file, as I told you that. So you should open that particular one output file by name called as .nam. .nam is important here. Why? Because NAM animator will always recognize only .nam files. So any file name you can give. .nam is in the right mode you are opening, and nm is a file pointer. Now what in our simulator, whatever nam trace hyphen all is a command. Whatever all the animation trace is there, all animation trace, you are storing that to the out.nam through $nm. Same thing has been done here also. That is for a trace file. You have to open one text file called .tr file. .tr indicates a trace file in a write mode, and nt will be the file pointer to this out.tr. Now observe carefully in a simulator $ns, in that simulator, whatever the textual tracing is there, all trace all is a command. So all trace all we are going to transfer to out.tr through $nt. Now, as I told you that after the simulation, that is, assume that for 20 minutes or half an hour or 20 seconds, it depends on your experiment, what time you have scheduled for entire simulation. So that I have told you that after doing the simulation, what you have to do, final stage. So that will be a common for all the, again, NS programs. That is, you are defining a finish function. So that finish procedure or a function will be called at the end of the simulation time. Defining, you can define whenever, means in beginning also if you want. That's why we are defining now itself. What we are defining within a function, that is the whatever variables are there, NS, NM and NT, we have to globalize that. Why? Because if I want to use the outside variables within a procedure in a TCL, the globalization is important using global command. Now whatever after the simulation, whatever the flush will be there in a RAM, that is simulator flush will be there, you have to flush all that particular. This means whatever data will be there, you have to flush all this. So that you will flush. Then afterwards you will close the NAM file, you will close the TR file. Then after closing the two files, what you are going to do, using a NAM animator, you will execute out.nam in a background. So later on you will exit from the program. So until here it's a common. And another one instruction is the last instruction, it will be there always, that after defining all the simulating components, everything, connections, everything, then you have to run the simulation. $ns, that is $ns means this simulator you are going to run. This is the last command which must be there. Always keep in your mind why I am teaching in this particular format. All common terms I am telling one thing. For all your lab 6 programs, these instructions are same. Right. Now, according to the problem, you will go. Now, according to the problem, where you will start after the finish function. So you will start. So in your problem, how many nodes are there? As we have discussed in a previous class that in our problem, there are 3 nodes. First, you create a node. How to create a node? Set N0 within square brackets. That, as I told you, that in a TCL script within square brackets command will be executed first. $ns in NS simulator, node is a command to create a node. After creating node, you are assigning that to N0 as a name. So like that, you are assigning N1, N2. Nodes are ready now, 3 nodes. Now you have to establish a connection, that is from N0 to N1, where 5 MB bandwidth should be there and 10 milliseconds, or N1 to N2, where 1 MB bandwidth should be there and 10 milliseconds delay should be there. So as according to the problem, you can see here, so we are defining the links. How to define a link? $ns in the simulator NS, create duplex link. Which type of link? That is duplex link, two-way communication link, or full duplex. So duplex link, that is where to where, from dollar $n0. If you give only n0, it's a character. So dollar $n0 from node n0 then to node dollar $n1 indicates node n1. So what will be the bandwidth of that particular thing? That is 5 MB and 10 milliseconds is a delay. Then drop tile is a queue between n0 and n1 node. Same thing for N1 and N2, but here the bandwidth will be 1 MB. So this is called as a movement scenario. Then how will you go with a traffic scenario? The next thing is that you have to create a traffic. How you are going to create this particular traffic here? Now set I will take one object for traffic, that is TCP0. As I told you that first a TCP agent must be created. So set TCP0 within square brackets, you can observe that new, I'm setting an object. New means dynamic object. I am setting as a TCP0. So new agent slash TCP capital letters. You have to give. This is must. We have no change. Why? Because it's a save file hierarchy. You have to give in that way only. So a capital letter agent slash TCP. That is in agent class file. You are considering a class called as TCP. So hierarchical. So then now TCP you are going to consider here. So this is very much important. How the hierarchy is there, like that only you have to give. The name shouldn't change and case sensitive also. Now TCP0 is a TCP object. Now you can use that object whenever you want. As in a problem that we have discussed, that we have to set the packet size also here. So in a TCP flow, the packet size will be defined in a TCP itself. So how to define a packet size? So in a TCP 0, that also in a problem they ask that 1500 bytes the packet size must be there, right? Now what you have to do, dollar TCP0 in that object, assume here set packet size underscore 1500. What do you mean by this instruction? This you must know carefully. In TCP0, that is in the TCP agent, set there will be a reserved variable called as packet size. Observe carefully. The reserved variables of the class will be always identified by underscore at the end. So here packet size, S capital letter, it should be like that only. If you give S small letter, it is wrong again. So packet size is a predefined variable, already existing variable in a class called as TCP, right? So packet size underscore indicates that it's a reserved variable, already it is there in a class. So packet size underscore is capital letter, and you have to give a value now 1500. Now you are setting in a TCP object, you are setting in a reserved variable packet size as 1500. Then what you have to do? The next step is like that, you have to attach this TCP with the node. So how to attach? In the simulation, that is $NS attach agent is a command. Attach agent N0 means to which node it has to be attached? It has to be attached to N0 by TCP0. You attach agent N0 with TCP0. So this is one command. Now in a drawing I have written that where node N0 is there, on that top I have joined and I have written that TCP0, right? That attachment now we are doing, that we are fixing on top of the N0, we are fixing TCP0. So that you can imagine. So once it is fixed now we have fixed that particular, we are attached this particular thing. Now after attaching this, what is the next step you have to do? Because of the source node N0, a application agent is also must here. So you have to attach application agent not on N0, on TCP0. This is very important. This application agent doesn't know N0. Why? Because in between TCP0 is there, means the TCP agent is there. On a TCP agent, we are fixing that particular application agent. How to fix that? Now you see, set FTP0, observe carefully, FTP0 as new agent slash, yeah, agent slash, sorry, sorry, it's not agent, application, it's application protocol, right? FTP, application slash FTP. Right, now close this. Now, once the new application slash TTP, that is in application group, FTP is one class which will be there. Here in a agent group, TCP is a one class which will be there. Here UDP will also be there in a agent group only. Why? Because there's an agent layer. On an agent layer, the application layer will be there. So that's the thing you must keep in mind. Now, FTP0 will be an object for FTP here afterwards. Now what we have to do? Now we have to connect that FTP to TCP0. That is important. How to connect that? $FTP0, whatever is there, you attach agent, means you attach that to $TCP0. Now source side connections are over. How? What we have did, we have taken a TCP0 as one agent or an object defined with TCP, and I have set a packet size to 1500 and I have attached that to N0. Right, that's the one part. Application agent I have taken as a FTP0 defined to the FTP class. Then I have attached that FTP0 to $TCP0. After doing this, now you come to the destination side. In a destination side, as I told you, that only transport agent is required. That's it. So how, if TCP is a very important, if TCP is a traffic here or a source agent, then at a destination, TCP sync will be there always. This is must. If your TCP is there at a source, at a destination, TCP sync must be there. So how to define that? Observe now here, set sync 0, sorry, new agent, this is also agent, slash, observe now, TCP is capital, sync. Remaining are small letters. Sync, correct? Spelling is right. Even one letter spelling is mistake, then it will tell it's an unknown class. So you must be very careful in that part. You will feel it's easy now, but while doing on own, if you miss any one letter or if you give small letters like that, again error will be there. Now set sync 0 and I am defining a agent, means within a square brackets new agent slash TCP sync. Now at a destination, I have created an object called as sync0, which is called as TCP sync. Now what is the intention here? Then I have to attach that sync0, that is TCP sync, to the destination node. Which is a destination node now according to our problem? N2 is a destination node, right? So in our simulation, that is $NS, attach agent, so N2 with sync0. Now the entire thing has been done. Means here destination side we did connection, and here source side we have did connection. Then another one important statement. Usually every student will miss this statement, thinking like that everything is over. After doing the source connections, after doing a destination connection, what is the next thing is there? I have told you in a drawing that a virtual connection should be established from TCP to the TCP sync. How you are going to do that? $NS connect $TCP0, sorry, TCP0 with $sync0. This is important. So finally you are telling you connect this TCP to TCP sync via N0, N1, N2, sync0. It will be connected like that. This statement is important. Usually this statement will be missed by students always in a lab examination. So where they will error will not be given to you, but packets will not flow. So this is a problem in NS simulator. Why? Because defining an error itself is a problem. So this is a one the connection of an entire traffic scenario. Now traffic scenario we have did everything we have did. Now I repeat once again. You can imagine now. First we should identify which is source and which is destination. For a source, you need two connections. One is a transport agent connection and another one is an application agent connection. Very simple. You do that. If TCP is a transport agent, then automatically you can set up packet size there only, and then FTP will be the application agent. That is common here. Now coming to next, the next one is the destination side. If TCP is the transport agent, definitely at the destination there must be a TCP sync as a agent, means acknowledging agent. So that should be there. Finally, you are going to connect TCP0 with $sync0. Coming to the next thing. Okay, now everything is okay in our simulation. We have defined the movement scenario topology. We have defined which is source and which is destination, and what type of data should flow from source to destination. That is FTP data we have told. Then what is the next thing? When to start your simulation? Time scheduling is very much important. The scheduler is very much important. When to start FTP flow, when to start UDP flow. Assume that both flows will be there in one problem. So when UDP should start, when FTP should start, when it should stop, when the UDP should stop, or when total simulation should stop. So that is another one important thing which we should define. The next part of a program is we are defining an event. So that is $NS, sorry, yeah, $NS, oh, right, $NS at I will tell like this 0.0 second, just at the start of the simulation itself. Observe carefully now. $FTP0, whatever, sorry, FTP0, whatever the FTP I have defined, application flow, that you have to tell. Start is a command. Start. Within double quotes only you have to give. This is very much important. So if you miss double quotes, it don't work. So $NS in a NS simulator at 0.0 second, you start FTP thing. That is $FTP0 start. You are going to tell. For example, when to close. Assume we want to close at 10th. Our simulation should be 10 second simulation. So exactly at 9.9 second, I want to stop the flow. That is $FTP0 stop. Means it will stop that particular flow. Why I given 9.9? Exactly after the simulation, I must do other work. That is, I should call the finish function. Correct? No. So next statement will be $NS at 10.0, exactly 10 seconds. So within double quotes, finish you call. That's it. Finish. Right. So you are going to call the finish function. So now, finally, the last statement should be run. Where is that? Yeah, run the simulation. This is the last statement. It should be there. Otherwise, it won't work. So after everything, means time scheduler I did, traffic scenario I did, movement scenario I did, everything I did, output files I defined, and final function, finish function I have defined, simulator I have defined. So finally I should tell run. So save now, save this and close this. Now observe carefully how to run the NS2 program. That is NS $, sorry, NS, what's the file name we have taken? Example 1 -NS2.tcl. Right, NS is a command to run, not TCL/sh. TCL/sh is only for raw TCL. For NS simulator, NS is a command. NS space exe1 -NS2.tcl. Enter. Now, see, this is the error. What is the error here? Here error it's telling very clearly that dollar node attach dollar agent. So at that particular thing, it is telling that N0, the dollar NS attach agent N0 TCP 0. There is a error in that particular thing where you can't attach that particular. Maybe I did a mistake here. So we'll go back to the program. We'll check what is the mistake here. So back here, where is it? Yeah, see, you can see here, I've given only TCP. This is very much important. I've given only N0. That is, N0 is a character now. It's not a node. Keep in your mind. So this is an error. Are you seeing the error very clearly here? Now dollar N0, if I give, that's a value. Value is node here. So dollar TCP, then it will become an object. Otherwise, just characters TCP 0, right? So that I did now, not an issue. Here also same mistake. N2 I have given dollar N2 dollar 60. Finally connect 60. Yeah, now I think I solved the problem. Close this. Now see the error. Observe here error. Here nowhere it has told dollar symbol is not there. What you can see here, this procedure simulator agent, it's giving a error, not a error of the directly of the your TCL script. It's a error which is linked with your C++ file. That is a confusion here in always NS. So you must be very careful that you must see the last line always. That is $NS attach agent N0 and TCP0. Some error is there here. Like that you have to see. Almost all it's telling that the invalid command name N0. So it's thinking it as a command. If you give dollar, then automatically it will become a variable. So that is a one analysis of the error. Now see here again. Yeah. Now it will run. No error. See. Now back here. It is run. The program is run successfully. Now a NAM console has been opened. The network animator has been opened. Don't close this. This is an introduction window. It should be there always until your simulation will complete. Just put it onto the taskbar. Now you see the animator here. Study of the animator is also very much important here. What is this animator? You can see this is an animator, means NAM animator, where the animation of packets or your connection you can do. Now according to our connection, N0, 1, 2 is there. So 1 is will be in the middle. Now if you want to edit this particular connections, you can edit here. That is, you come to first edit mode. Once if you come to the edit mode, now you can handle these things easily. See how it's coming this side, it's coming that side. So wherever I want the sorry, what am I? Just a minute. What happened? I think it's gone bigger. Just 1 minute. See, it's gone very big. Just 1 minute. We have to be careful here. Just I'll close this window once again. I'll run this. Don't worry. Yeah, I closed this. Once it's gone out of things, means it's difficulty. Yeah, now it is there. Now see, I'll come to the edit mode. Just slowly you do this. Hold it, drag it. Yeah, now it's coming. So yeah, now it is there. Right. So this is edit mode. View mode. View mode means you can't do any changes here. That's it. Just you can view the things. There's a one thing. Then this is a time bar. Means it will shows the time when it's starting time and a closing time. You can know in between. And coming to here the buttons. That is, there's a play button. Either you want to play, means the simulation you want to do from right to left, you have to use this play button or this particular play button. Now observe carefully, usually from left to right, the simulation we are going to do. Usually our things will be like that. So this is a play button and this is stop. In between, if you want to stop, you can stop this. Then what is a step here? This is very much important. What is a step here? Sorry, a time to time gap. The step, it is of 2.0 milliseconds. That is 0 second. What is the next pulse? 2 milliseconds, then 4 milliseconds, then 6 milliseconds, 8 milliseconds, like that it will count will be there. Means your pulse will be moved in that particular format. If you want to make it more pulse, means if you want to complete your simulation very fast, you can fix that wherever you want. The default, it will be there as always, the to this one. Sorry. We came here, that's a two, yeah, it came to macro. Wherever you want, means macro means still it will be very slow. Yeah, 2 milliseconds, let it be. Power one clock pulse, let it be 2 milliseconds. Whatever you want, you can fix. That's not a thing here. So if you want more clarity results and all, default will be 2.0 milliseconds. You can reduce it or still you can proceed it. You believe or not, we will do, means myself, I have did a simulation research experiments for 500 minutes or like that, 100 minutes, 500 minutes. So we used to do like that whenever a large experiments we are going to do. Now just run this. This is a run. I'll click here. Are you observing here? The packets are moving, right? Moving, right? Yeah. That is, observe here, 0 to 1 it's coming, and again here somewhat jammed. That is due to less amount of data. It's very jammed here. Here somewhat a gap is there after. But same 10 milliseconds, it's not here. It's very fast here. And here you can see from 2, the acknowledgement is coming back from a sync to 0. Either the received packets acknowledgements is coming back. So you can see this is a default program. For example, now I want to change this packet flow color. If you are wishing to change that color, you can change it. Or if you want to label the nodes, you can label that particular nodes. So if you want to change the color, yeah, you can change the color here, not an issues. So in this way, the animation will be done. So you can do it. Or if you want to make it a fast, just drag this. It will be very fast. Now 63.1 millisecond 1%. That's why it will be very fast. Done. 10 seconds has been completed. So I have told you that there will be 2 output files. That TR file must also be there, right? No. So just I will do ls and you check it out. Here out, where is that? Out. Out.tr. It is also there here. Are you seeing? Automatically created. What will be there in that? We'll check it out. Edit out.tr. Now you see this is out.tr. So according to the columns of a data, we are going to evaluate this. If you see this, you will feel, what is this? I don't know anything, right? So to know this correctly, you must have the column headings. I mean, you must know what for that column is there. Here, the first column always represents what event it is going on. What do you mean by this? The plus indicates that NQ. NQ means getting into the queue. DQ means going out from the source or going out from the queue. That is DQ. Observe carefully. I am telling very clearly. The first column indicates the event significance. That is, the plus tells that enqueued. That means entered into the queue. Means who entered into the queue. Packet entered into the queue. Right. Of node number 1. That I will tell later. Now, minus means gone out of the node or gone out of the particular node or a queue. So that is D queued, right? Now coming to R. R is received at one place. So to indicate received, so that is R. The another one will be there, that is called as D. D means dropped packet, right? Drop. D means drop. Note down this. Plus means NQ, minus means DQ, R means received, sorry, D means dropped packet. Now this each line indicates each packet information that you have to keep always in your mind. Now the first packet information will be like this. So this is the first column. What will be the second column? The second column is nothing but a time. The second column indicates time. At that time, what happened? So the second column will always tells time. That is 0.010064 is a time. At that time, what happened? Now observe here, R is a received at 0.010064 second. What received? The third column indicates source node. The fourth column indicates destination node. From 0 to 1, a packet has been received. One received the packet called as R here. Are you getting? So what is the type of a packet? That is TCP. What is the size of a packet? That is 40. So that you have to keep in your mind always. Everyone, very clearly I am telling you. Very clearly I am telling you. Again, I will tell what for the columns. The R is a event significance column here. The first column is a event significance column. There, plus minus RD will be there. Plus indicates enqueued, minus indicates dequeued, R indicates received, D indicates dropped. Second column indicates time. Third column indicates source, which source the packet is moving. The fourth column indicates destination node. The fifth column indicates type of the packet, either TCP or acknowledgement. Then again, the sixth column indicates size of the packet. This is very much. Now you see the size of the packet we have defined, observe carefully here. The size of the packet we have defined as 1500. But for a damn surprise for us, here 1540 is there. Why? So while I'm teaching you the protocol, means the IPv protocol format, 40 bytes is the default header size and 1500 bytes will be the payload. So whatever a packet size you are defining, that will be the payload. 40 default will be added to that. That you have to keep in your mind. For example, if I tell my packet size is 1460, then 40 will be added to that. And again, it will become a 1500 round figure. So here I have given 1500 as a payload size, then 40 header size will be added. Then it will become 1540. That you have to keep it. I want only data from this. I want to remove header means you have to remove 40 from this 1540, right? Then remaining columns and remaining flags is not at all related for analysis. Only the column number 1 to 6 is related in a analysis. That I will tell you later. Don't worry about this. For your stage of learning, 1 to 6, this columns you must know the analysis we are going to do in this particular output file where graphs you can generate. For example, assume in this case I will ask you how many packets are dropped. Just for a sec, how many packets are dropped? Here what you have to do, you have to extract a means rows where the first column is a D. So using AWK or a grep command, you can do that. You have to extract that and you have to count how many D lines are there in this entire file. On your imagination, I will tell you that just I did 10 seconds of simulation. Am I right? Just I did 10 seconds of simulation. Imagine how many lines of tracing lines or packet, how many packet details will be there here. You see here, I'll go to the last line where it will show the count of the lines. See the last line, 9,685 lines. That means 9,685 packets has gone from here to there and there to back. So keep in your mind, including acknowledgements. So that many lines of tracing is their year. So in that we have to extract our own data according to the problem. So in this way the analysis will be done. That you have to keep in your mind. So coloring of a packets, that and all I will tell you later. Don't worry about that. So tomorrow 8:30 there will be in a class. I will start with the lab program. Sorry, I will start with a lab program. So once the first lab program, first and two, I'll try to complete. If it completes, we'll go with the theoretical thing. After doing two programs, we'll go with theory, and later on we'll come back with the another two programs. Right? Uh, just I will stop sharing of this. Now just for a sec, yeah, back here. Now whatever the program which I have did, I will take a snapshot of that and I will send to you, even though you do in your the VMware. Try to install first NS2 software. If it is not there, usually it will be there in our VMware what we have given. Why? Because default NS software will be there if you are taken from our lab. No need to install again and again. Check it out. In a root directory, NS all-in-one folder must be there. In that folder, NS 2.34 folder will be there. Once NS all-in-one folder is there, it means that NS simulator has been installed. So if at a root prompt and all, NS is command is not working, it's still unknown command. So what you have to do, you have to go to NS all-in-one, open that. Their bin directory will be there. Open that. Take all the files, copy all the files, 13 files, copy it in one shot. Copy, paste that in SBin. Come back again. The SBin will be there in a Unix file system. Go to computer, press there, file system, open there, SBin, open it, paste there. And come back to the terminal at again root prompt, that is hash prompt. If you type NS now, it will work. Maybe that step you have to do, I think, in the college software what you have taken. Okay. Thank you very much. I'll try to send that snapshot of the program where you can practice it still tomorrow. Tomorrow I will take a class. Hello. Tomorrow I will take a class at 8:30 or within 5-10 minutes difference. I'll take, be waitful there. Okay, attend the class. Thank you very much.
Thank you, sir.
Thank you, sir.
Thank you, sir.